Today we will study about the electric current. So in the previous class we have started the basic concept of electricity, and in that class we understand that electricity is associated with the electric charge. Because of this charge there is an electric current, right? So we will study about the electric current and how an object and a substance is charged. Okay? Now, electric current. See, when water flows in a river, we call it water current, right? And moving air, wind, we call it air current, right? So in the same way, the flow of electric charge in a conductor in a particular direction is known as electric current. Very similar concept with the flowing of water in a river, we call it water current. Moving, flowing, right? In the same way, the moving of these charge particles, the flowing of this charge in a conductor in a particular direction is known as electric current. It's very simple, right? So I have made a box here in the conductor because electric charge will move or flow in a conductor only. There are two substances you need to understand before we move further, right? So conductor are those substances through which electric charge can flow very easily without any considerable resistance. For example, metals or aqueous solution, salt solution, or all ionized gases. Okay, those are the examples of the conductor. So like copper wire and all. In the copper wire and all, the electric charge can flow. So insulator are those substances in which electric charge cannot flow or do not flow easily. They offer high resistance. Okay, like rubber, plastic, porcelain, and pure water, etc. Those are the examples of insulator. So current will flow only on conductor. Okay, now let's move forward. Electric current is expressed as the net flow of electric charges per unit time. In per unit time, okay, across a cross section of a conductor. For example, let's take an example. This is a wire. Okay, let's say this is a wire. In this wire, there are electrons, the electric charge. So, for the first definition, the flow of charge in a conductor in a particular direction means it will flow in one particular direction. Let's say it is flowing from the A to the B direction. Okay? But one thing you need to remember is that electric charge cannot flow on its own by themselves. Okay? There has to be something which will make the charge to flow in one particular direction. Understand? That is called potential difference, and we will study in the next class. Today we will study the directions of the current and the electric current. So, in the conductor, when the potential difference is created or provided in this conductor, it will flow in one particular direction, let's say from A to B. Okay. One more thing here. This is a same wire. Okay. This is number 1. Let's say this is number 2. Electrons, the electric charge are here. Metals, in the metals, the electrons are loosely packed, means they are free to move anywhere. So before the potential difference is provided here, okay, what happened is created here. Before the potential difference is created, what happened? All these electrons are free to move. They are moving in all possible directions. One is moving this side, that side, in all possible directions, which means it is moving randomly in a metal. Okay, so if I keep a piece of wire there on the table, there will be electrons which will be moving in all possible directions randomly. But once I connect this wire with a battery, the two ends, if I connect it with a battery, the two ends of this wire, what happens? Potential difference is there in that battery. Battery is a device which maintain a potential difference. So question might come, name a device which maintain a potential difference. Example, answer is battery, cell. A cell maintains a potential difference. So if it is connected with the cell, what happens? Then all the electrons in this conductor start moving from one particular direction, from, let's say, from A to B, which was moving randomly in all directions. Now it will be moving in one particular direction. And which direction it will be moving, we'll discuss more. So if this is a battery, a cell, if it is connected from a battery, a cell has two terminals, right? Positive terminals and the negative terminals. And inside the battery there is two chamber which is divided into half like this. Okay. So the bottom part, the negative minus part, the negative terminal, they are filled with electrons, negative charge, and the upper portion is filled with positive charge, protons. So this is electron, this is proton. Okay. So once the two terminals of the cell is connected with the wire, what happens? All the electric charge, the electrons start moving from the negative terminals to the positive terminals. So this positive terminals is known as the higher potential. Okay, higher potential. This is higher potential. This is low potential. Okay. So electric charge, electrons flow from the low potential to the high potential, and the directions of the current is taken opposite to the electric charge, to the electrons, for our convenience. So for conveniently, electric current, directions of the flow of current is taken opposite to the flow of the electrons. So electron flows from the negative terminals to the positive terminals, means from the low potential to the high potential, and the electric current flows from the high potential to the low potential. So this is electric charge which is moving from A to B, or electrons. Okay, and this is electric current which is moving opposite to the flow of the electrons. Okay, electron moves from A to B and electric current moves from B to A. Understand? So always remember that the directions of the flow of electric current is from the higher potential to the low potential, and the directions of the flow of electron is from the low potential to the high potential. They are opposite to one another. Okay, that is taken for our convenience. Now, the next portion here, what you see here is that electric current is expressed. The net flow of electric charge per unit time. Per unit means 1 unit means 1 second. Across a cross section of the conductor. So this is the conductor and this is the area, the cross sections of this conductor. How many electrons can fill in this conductor and how many electrons are moving in 1 second. That is the net flow of electric charge per unit time. I mean, in 1 second in this area of this conductor, in this cross section, how many electrons are moving. Okay. Now electric current is denoted by this letter I capital, and if let's say this Q is the charge, okay, which is moving in this conductor, flowing in this conductor in time t. If Q charge is moving in this cross section area in the per unit time t, then electric current is given as current equal to charge upon time. So we can measure how much electric current is flowing by this relation, by this formula. Okay. So in 1 second in the cross section of this wire, how many charge is moving? That will determine the current flowing. So formula is I equal to Q upon P. Okay. Now the SI unit of electric current is it will be the SI unit of the charge upon the SI unit of time. So what do we know? SI unit of charge is what? Coulombs, right? So in Q it will come C, and the SI unit of time T, it will come second S. Okay, so this unit charge upon time, which is coulomb upon second, right? This unit is also known as the ampere. Okay, and ampere is denoted by the capital letter A. So in this class we have learned about the electric current, directions of the flow of the electric current, and the directions of the flow of the electric charge. Okay, and then the SI unit of the electric current, and also the relations, the formula I equal to Q by T to find out the amount of electric charge which is flowing. Okay, electric current which is flowing in this cross section of this wire. Okay, sometimes questions might come like define 1 ampere, or what is a 1 ampere. So current through a cross section is said to be 1 ampere if 1 coulomb of charge flows through it in 1 second. That means this is our conductor, a wire, let's say it is a copper wire, and in this cross section area of this cross sections in this conductor, if in 1 second 1 coulomb of charge flows through it, that is called 1 ampere. Okay, you can write down this definition, and some points to remember is that charge of 1 electron is, we already learned in the previous class, 1.6 into 10 to the power minus 19 coulomb. This is the charge, the magnitude of this charge. See, in 1 coulomb, how many charge? 6 times C into 10 to the power 18. So that means if in a conductor, if 1 coulomb of charge is flowing, so don't take it lightly, it is a huge amount of electric current which is flowing, because 1 electron carry this charge, a magnitude of 1.6 into 10 to the power minus 18. That is 1 coulomb 6 times greater than this, into 10 to the power 18 charge. Okay, there are many charge, so many. Okay, now there are smaller units to measure the small amount of current. Milliampere we have, which is denoted by the small letter A and small letter M and the capital A, and its value is 10 to the power minus 3 ampere. And smaller than this milliampere, we have microampere. So we have ampere, milliampere, and a microampere. Micro is the smallest one, which is denoted by this mu capital A, and the value is 10 to the power minus 6 ampere. Basically, we don't use this milliampere and the microampere. We use only the 1 ampere. Okay, we use only ampere. Now, ammeter is a device to measure the flow of electric current in a circuit, right? And the ammeter is connected in series. Okay, so you can write down these points, and in the next class we'll study about we'll study more about it.
Stay home, stay safe, do